Good morning, guys. Today we're going to go over the remaining examples of 3.4. Now, real quick, examples 3 and 4, I'm not really going to review because they're pretty straightforward. All you have to do is use, a condensation, so the additions become multiplications and the subtraction becomes divisions. So, again, pretty straightforward. You should be able to manage those. Now, we will be focusing on examples 4, 5, and 7, which are slightly more complex. Now, for example 5, I'm given the following expression. 4, and then as an exponent, 3x minus 1 equals 3, and as an exponent, 2 minus x. Now, the first step, again, in this case, normally if we just had one side, you would put log base 4, cancel, and drop down the exponent. The problem is, if I multiply this side by log base 4, I would have to multiply this side by log base 4, then there's no way to cancel. And vice versa, if I multiply both sides by log base 3, there's no real way to cancel. So what you actually have to do is multiply by a different log. It could be a common log or natural log. It could be any log. But just to keep it, simple, let's multiply both sides by natural log. This side gets multiplied by natural log. This side gets multiplied by natural log. Now note that all of a sudden, these become exponents of, logarithms. So using the rules, they can come up front. 3x minus 1. I'm going to put a parenthesis there. And this comes up front. 2 minus x natural log 3. So all I did in this step was, two steps. First, multiply both sides by natural log, then the exponents came up front following the normal rules of the logs. Now, note that these are multiplications, so I'm going to do the distributive property. So this becomes natural log 3x minus, plus natural log, 4, I forgot the 4. Wasn't making sense. Give me 1 second. So when I multiply, again, 3x natural log 4 minus natural log 4, again, you multiply, equals 2 natural log 3 minus x natural log 3. Remember, when you multiply logs, you don't multiply this number by the number of the log. You just multiply it by the front coefficient, which would be 1 in this case. So now, here's where most students get lost. Again, so far the process has been pretty straightforward. Multiply by a log, drop the exponent, distribute. Now note that some of these have x's and others do not have x's. So all I'm going to do is group all the ones that have x on one side and all the ones that do not have x on the other side. Doesn't matter which side, choose one. So I'm going to send this natural log 3 over here on this side by addition. So I'm going to have plus x natural log 3. Again, remember, I add this on this side, I add it on this side. This side cancels out. That's how I got it on the other side. Equals, and this number that does not have a natural log, I'm going to send it to the right, also by addition. Remember, what I add or subtract or multiply or divide or exponentiate on one side, I have to do on the other side to maintain the equality. Okay, now that I have this particular expression, we're going to start condensing the logs. And here's where it gets a little tricky. So let's focus on the right-hand side. These logs have the same base, so they can be condensed. Now, an addition becomes a multiplication. But before that, we have this coefficient, which must be exponentiated first. So this 2 gets sent up to this 3 as an exponent. And when I condense these two, I have natural log of 3 squared times 4. Again, because the 2 went up as an exponent. Now 3 squared is 9 times 4 is 36. So on the right hand side, I have natural log of 36. Here on this side, pretty much the exact same process is going to happen. Okay, one thing before that. Here, I had nothing in common. So you just do the process. Here, I have x's in common. So you're gonna do a common factor. Let me just lower the camera a bit, sorry. So you're gonna do a common factor here, and they both have an x in common. So on the left-hand side, I'm gonna have an x in common, and then I'm gonna have 3 natural log of 4 plus natural log of 3. And now I'm gonna do the exact same process as I did on the right-hand side. I'm gonna start condensing. This 3 jumps up here as an exponent, and I'm left with x natural log of 4 cubed. Give me 1 second. I copied it incorrectly, that's why it wasn't making sense. You have to be very careful. That wasn't an exponent, that was a value here. So now, of course it makes sense. So now you multiply the 4 cubed times the 3. So on the right-hand side, I'm gonna have 4 times 4, 16 times 4, 64 times 3. 60 times 3 is 180. 4 times 3 is 12, 192. So you're gonna have on the left-hand side, x natural log of 192 equals natural log of 36. So again, you've seen all these processes we've done just to solve this particular one. They are long, they're not that difficult, but they are very long, so you have to be very careful. What do I do now? This is a multiplication. So I'm gonna just divide. Remember, all you have to do now is calculator. There are 2 things you can do. You can find the value of natural log 36 and divide it by the value of natural log 192. Or, you can just make it easier on yourself. You can combine, since they have the same base. You can just divide this number and then in the calculator do the natural log of the answer. So that covers example 5. It's a little tricky, but you do have to manage. That was example 5, solved in logarithmic terms. That will show up on the test, by the way. We're gonna go over example 6 today, and then we're gonna leave example 7 for Monday, just in case, so this video isn't too long. So in example 6, even though it looks a little tricky, it isn't. You should recognize this as a quadratic form. 3 terms, a constant, and the first or the leading coefficient has an exponent that is double the middle coefficient or the following coefficient. So this should look, again, remember, like a quadratic form. Okay. It looks, this camera is so awesome today. Okay, so this should look like a quadratic form, x squared plus x plus a constant equals 0. Now, what they do to work on these specific problems is the following. You're gonna substitute the letter E for the letter U. Again, just to make it simpler. And you're gonna use the you're gonna list it in this fashion. Okay, you're gonna, oh, I forgot the 6 as the coefficients. All they're gonna do is substitute e to the whatever squared, and then whatever number to whatever exponent, you're just gonna change it as a u. If this were a 4 and this were a 2, you would put a 4 here and a 2 here. But since I have a 2 and a 1 in front of the e, I'm gonna use a 2 and a 1 here on top of my u's. Now you're gonna factor these as a standard quadratic. Just factor them as you would factor a normal quadratic. Two numbers that multiplied give you this and added give you this. U minus 8 and U plus 2 equals 0. I multiply these two numbers, I get negative 16. I add these two numbers, math teacher working. There we go. You're probably shouting at your screen, profe, mediocre. Here, again, now it's correct. These two numbers, when you multiply them, you get negative 16. When you add them, you get positive 6. And again, remember, this should look like a normal quadratic factoring. And what do I do now? All you gotta do is check what this answer or what this solution would be. This solution would be the following. And again, you have to write it. You do have to do this process. You say one solution should be negative 8, because again, when you plug it in here, it's going to give you 0. The other solution should be positive 2. Okay. And again, you should know that u was e to the x, because that's what we substituted the u for, e to the x. And I had that e to the x equals negative 8, and e to the x equals positive 2. Again, right now you should know how to solve these particular exponents. You just multiply both sides by natural log. This is a multiplication. These cancel out, and you're left with 1x equals natural log of negative 8, and the other x equals natural log of positive 2. So again, let's go over the steps one at a time. For example 6. You copied the equation, you substituted e to the x for u. So in the first one, since I had e to the 2x, I believe it was, you substituted for u2. U2. Very bad music group. Tired of them. They were very good a couple of years ago. And again, the second one, which was 6e to the x, you just substituted for 6u. Again, wherever you see an ex, you're just going to change it for a u, and you're going to leave the exponents as is. After you change it for a u, one thing, it's not necessary to change for an u. You can just break it up without actually having to substitute. But the book does it to help you visualize that substitution and help you factor just a little bit easier. But you do not have to substitute. It just makes it easier. Again, once you substitute, you factor. After you factor, you find the solutions. You state both solutions as u equals one solution and u equals another solution, so whatever, x1, x2. And then you have to substitute the u's for the ex and then solve for these variables normally. That's it for example 6. We're going to go ahead and do example 7 on Monday just to keep this video short. So have a great day. Take care.